All right, so first proof we already did yesterday. It's on page 29 if you want to try it again and see if you got it right. Boom, here you go, second proof. Go ahead, set it up. Highlight your overlapping triangles. Mark your diagram, and we got some talking to do here. Alrighty, all the highlighting, markings, hopefully are on your diagram right now. All right, first thing I always like to take a look at is, in the givens, were you provided with sides or angles at all? In the givens, were you provided with full sides or full angles for the two triangles you're trying to prove congruent? So the only sides I was given was AX and AY. Can I use those as full sides? Look at your diagram. Look at the triangles we're trying to prove congruent. Are AX and AY full sides or not? Here we go. Liam, are they full sides or not? AX and AY.
Yes.
Yes, they are. So I'm going to, everyone, this is why I'm putting in S next to them, because I have a full pair of sides. And as you guys know, you need 3 pair total. The one S alone won't do it. Where else do you see angles or sides I could use in the diagram? Let's keep this going. Nothing new. I'm showing nothing new here. Here we go. Niall, do you see any other angles or sides you could possibly use?
The two perpendicular angles, right?
What are perpendicular angles? That's a new term for me.
The angles that are formed by the perpendicular line.
And what type of angles are those called, Niall? You got this.
Right angles.
Okay, name them. Where are the right angles?
AYB and AXC.
Good job. And notice Niall didn't fall into the trap. I marked them on your diagram. That doesn't mean they're in your proof yet. So angle AYB and angle AYB and angle CXA are right angles. Perpendicular lines form right angles. All right, keep going. What else do you want to say? What else should we write down here? Here we go. Eric, what do you got for me, boss?
Angle AYB is congruent to angle AXC.
How do you know they're equal?
All right angles are congruent.
Good job. Great job. And Eric just gave us a pair of angles. One more to go, kids. Can you find it? One more pair of angles or sides to go. Where is it? Where is it in the diagram? Come on now. This is why we highlight for this. Settle down.
Are you doing sorry.
Yeah, you should be. What's your question or comment?
Am I allowed to answer this one?
No.
Okay.
But your number will probably come up, and that's karma for me. Watch this. All right, everyone. This is why we highlight for this specific reason, so we can see this third pair. It comes up 6. Woohoo! I was close. Niall, go ahead. Do you see it, Niall?
What was the question again?
Where's the third pair of sides or angles I need?
BY and AC.
How do you know they're congruent?
I don't know.
Okay, all right, it's fine. You probably conspired with Christo here, so I could call another number. Oh, close, so close again. Tim.
Angle XAY.
Angle A. What do you know? Look at your diagram. What do you guys notice about angle A? It's in both. It's shared. I can have a reflexive angle. Angle A, congruent to angle A. Good job, Tim. Reflexive. There is your third pair of equal parts. There you go. Angle A, congruent to itself. Yep.
Could you say that B and C are congruent because across from congruent sides are congruent angles?
It's got to be in the same triangle.
Okay.
Okay? See how you're using two sides from two different triangles?
Yeah.
The angles across are not equal. They have to be contained in the same triangle. So now I could say, here we go, triangle BYA is congruent to triangle CXA. Ooh, but the hard stuff's not over yet. I got two angles and a side. Is it going to be angle side or angle side angle? Woo! Are those sides in between or not? I'm having a hard time looking at the diagram. Anybody remember the suggestion I made if you're having a hard time looking at the diagram? How to make your life a lot easier. I can't tell just by the diagram. Any suggestions for me that I could tell? So I could tell a little easier if that side's in between or not?
You can draw it like outside, like redraw it.
Take one of the triangles. Thank you, Sarah. Take one of the triangles and redraw them. So I'm going to take triangle AYB. Everyone see that triangle I just pulled right out of the diagram? AYB. What did I mark on AYB? Give me one marking I put on that triangle, and where is it?
The right triangle, that's angle BYA.
Right angle at Y. What other markings are on this triangle? Angle A, reflexive. And then what side did I mark on this triangle? I did. I marked AB.
AY.
AB is this right here. Right? I didn't mark AB. I marked AY. Is it pretty easy to tell now? Good. Now tell me what the method's going to be then. Here you go, Niall. Redemption.
Angle side angle.
There you go. Questions there? Do you think, oh, maybe I was overhyping this, right? It's not that bad. Did I overhype that one? Not that bad? Did I overhype that one? I probably did. You better buckle up. You kids at home, if you got tissues around, you might want to get them because there might be some tears or some bloodshed. You guys in class, my tissues are right over there in the back if you need them. All right, might be some tears here. Go ahead, set this up. Let's get rolling. Okay. Did I give you a pair of sides or angles? Do you have anything to start out with? All right, everyone look at your givens right now. You have two givens that I provided. Look at them. Are those anything I could use as far as sides and angles go? In the triangles I'm trying to prove congruent. Did I give you any sides or angles to start out with? Whew. Eric, did I give you any sides or angles?
EH is congruent to EH.
Oh, no. Oh, you're getting a step ahead of me, Eric. Getting a step ahead. I was asking in the givens, Eric. in the givens.
Sorry, my dog's
It's fine. I love it, by the way, Eric. I love it. It brings more personality to the class. FH and GE. Are those full sides?
Yeah.
Yeah, there you go. So that's what I was asking right there. I gave you a full pair of sides. Everyone sees that. All right, so where's the other two then? I don't know if anybody heard Eric. Hopefully you're focusing on his dog more than what he was saying and didn't hear what he had to say. Where else is a pair of sides or angles? Oh, look at that. Eric, you got it now. Now you can tell me where the other pair of sides are.
EH is congruent to EH.
There you go. Can I ask real quick, Eric, dog's name?
Petey.
Petey. Nice. He's in agreement with you. He sees EH congruent to EH as well. This is way too easy. What is he talking about? These are going to get harder. Look how quickly we just found two sides. This is why it's about to get tough. Right now and all day on Monday. Is because that third pair, you are going to have to dig real deep inside you to figure out what that next angular side is going to be. It will not come as easy anymore. It's not going to be a reflexive angle like last one was. You guys are going to have to dig deep now and use your knowledge to try to find another side or angle. I will let you, I'm not going to come up here and just tell you how to do it. Absolutely not. Think through, where else could I get a side or an angle? And remember, there's still one given we have not even sniffed yet. We have not even touched one given. And you know it's provided for a reason to use it. Why did they give us those angles equal? Why? It must mean something to lead us somewhere. Oh, yeah, this is going to get tough. Where are those other sides or angles? Whew. I don't know if anybody sees it. I have faith in a bunch of you. You can find it.
I have it, should I say?
Oh, you think you have it, Tyler, huh?
I think I have it. I could be wrong.
I am willing to listen to your theory here.
Okay. Angle EFH is supplementary to angle GFM.
Oh, you can stop right there. What's supplementary mean? What's supplementary mean?
That they're linear pairs and they're not linear pairs.
And they have to add up to 180. They have to be a straight line, right? Then there's no way that's making a straight line, right? You're better than that.
Yeah.
Okay. You got a theory, Quinn?
Yeah.
Quinn's got a theory in class here. Let's see if I agree with it or not. I'm ready.
Angle EFH is adjacent to angle GFM.
Okay, I'm listening.
So, and then that means that angle HGE is adjacent to angle FGM.
Okay, they're adjacent. Sure. Where are you going with that?
So then adjacent, congruent angles that are adjacent to other angles are congruent.
That's just a made-up Quinn theorem.
Oh.
Yeah. You're thinking that only applies if they're supplementary.
Okay.
Okay? Not if they're that only applies if they're supplementary or complementary.
Okay.
If they're just plain adjacent, that's it. Nate, and then Adam's on deck. Nate, what's up,
I
buddy?
also have something.
Oh, that's nice to hear.
Would you say that triangle FJM is equilateral because of
F? I don't even know if there's a J. I don't think there's a J in this diagram.
No, never mind. I'm confused.
Okay, Adam, you're on deck. Christo, if he doesn't get it, I'll finally listen to you for once.
Line FM is congruent to line GM.
We're getting there. What's that? That's part of it's not the end game. It's part of the process.
But in a triangle,
Yeah, I know. Where are you going with that, though?
then we're gonna. Wait. If you add to EM and MH, but that doesn't. Or no.
All right, let's take a breather here, everyone. Let me just write down what Adam said because this is going to be part of the process. He said, hey, everyone look at triangle FMG. It has two angles equal, meaning what across from them are also equal. The sides. FM is congruent to MG. Because we know in a triangle, congruent angles are across from congruent sides. Again, this is not the end game. This is getting towards the end game. So I know these two now are equal. We're going to use it though. That's why I wrote it down. Let's keep going here. I have FM and MG. Remember, you're looking for an angle or a side here. Woo. Christo, would you like to now finally chime in?
Sure. Okay.
Are you, first of all, whoa. Are you going to use FM equal to MG?
Yeah.
Okay.
Okay, so in the givens, it was said that FH is congruent to GE.
Stop right there.
So we're
Stop. Does everyone hear what he's saying? I know where he's going. He said in the givens, FH is congruent to GE. We just proved FM is congruent to MG. What are you going to do with those two, Christo?
Subtraction.
I'm going to subtract. And when you subtract, what two segments do you have left over that are now equal?
EM and MH.
EM and MH are now equal and I'll write all this down in a minute when I subtract. Everyone with me so far? Why is that so great if those two segments are equal?
We can say that angle MEH and angle MHE are congruent.
The angles across are also equal, which is the final pair of angles I needed there. Everyone see that, what we're doing there? So let's show the subtraction first. Welcome to the big time, boys and girls. Welcome to the big time. We're getting as tough as it gets here now and Monday. So FH minus FM is equal to GE minus GM. Subtraction. And then, yes, substitution to say line segment EM is congruent to line segment MH. Substitution. And now I have an isosceles triangle at the bottom of my diagram. And what's across from those sides? Angle MEH and angle MHE. The theorem once again in a triangle, congruent, in this case sides, are across from congruent angles. And that, ladies and gentlemen, is the A that I needed to prove the triangle's congruent by side, angle, side. So step 7, the triangles are congruent by a method called side, angle, side. Expect the third pair to be a little tougher. Maybe not on the homework, but definitely start Monday again. I'd still want to open this up. Did anyone want to do this a different way? Because there's 2 other different ways to do this proof other than the way we just did. Did anybody want to prove a different pair of triangles congruent? So you could say CPCTC and then get a final side?
I was thinking you could maybe prove MEH is an equilateral.
It's not equilateral, nope.
Or is an isosceles, sorry.
Yeah, we did that, Tyler.
Yeah. And then I don't know what I was going to say now.
Well, we kind of did. We didn't say it. We didn't come out and say it was isosceles, but didn't we prove 2 of the sides equal?
Yeah.
All right. So we didn't write it down that it was isosceles. We didn't need to, but we basically said it was. We proved it was isosceles. All right. Everyone else, yes.
could approve MEF and, MHG.
You could approve triangle FME and GMH congruent, and then said CPCTC, FE congruent to GH, and then done side, side, side. There's one of, and then there's another pair of overlapping ones on there you could approve instead.
Oh, FHG and GDF.
Yep. And then same thing, CPCTC to say FH and GH. Yep. Good. All right, guys, you guys are good. Start the homework here. Get some rest over the weekend. Monday's going to be real strong. First two pair are very easy to find. Third pair, we got some work to do.